We're going to real quickly go over how to solve quadratics because this is kind of where we make that advanced mathematical solving when we're looking at some of the stuff we're going to see. So, steps for solving quadratics. First of all, before we even go that, quadratics is when you have a squared. So you have like an a squared or an x squared, and we have to follow those steps, okay? And I'm also going to be very honest with you. We're going to do the easier ones right now. This can get more complicated for sure. We're not dealing with that right now. We're dealing with the more easy ones, okay? So the first thing we have to do is we have to solve the equation for 0. We have to make the equation equal to 0. The second thing we're going to do is we are going to factor. Now, this is the hardest step. We're going to do the easier versions of stuff right now, but factoring can get really complicated. I also don't know how all of y'all have learned to factor. So I'm going to show you one method that works for right now, and then we'll get more into factoring later. Okay? Then step 3, we set our factors equal to 0, and then we solve. Okay? We solve the equation for 0, we factor, we set those factors equal to 0, and then we solve it. This is something you should learn in Algebra 1 in theory, but we're going to kind of pick it back up. Okay? So let's look at an example. Go ahead and pause if you need to write it down. So this is quadratic because of that squared right there. That squared is what makes it where you can't just solve it like a regular equation. Okay? Step 1 is to make it equal to 0. This one already equals 0, so we're already fine there. Step 2 is factoring. Okay? So here's what we're going to do because it's going to work for the easier ones. What factoring means is we're going to take this trinomial because there's 3 parts there, and we're going to put it into 2 binomials. If you remember with quadratics, this right here times this equals this right here. So what times what equals a squared? And the only option is a times a. A times a equals a squared. Then this times this has to equal this back number, which is 40. Well, there's a lot of options that work for that. So 40 could be 40 times 1, 2 times 20. 3 doesn't work. It could be 4 times 10. Could be 5 times 8. 6 doesn't work. 7 doesn't work. And then we're back to 8, which I already have. So this is everything that multiplies to 40. So which numbers are we going to use? Well, we're going to use whichever combination can either add or subtract to that -6. And don't worry about the negative right now. Just worry about the 6. Okay? So if I add or subtract 40 and 1, am I going to get -6? No. I'm either going to get like 41 or 39. So no. Can I add or subtract 2 and 20 to get to -6? No. I'll either get 22 or 18, so that's not going to work. What about 4 and 10? Yes, I can make 4 and 10 become a 6. So it doesn't matter the order that you do, 10 or 4. I'll just put 10 first and 4 second. Although I could have switched, it doesn't matter. And then it has to equal -6. So if I make these both positives, that's not going to work because 10 plus 4 is 14. So that's not going to work. So how can I make a 10 and a 4 add or subtract to -6 is it's a -10 and a +4. Because -10 plus 4 is -6. And that also makes sense because -10 times 4 is -40. Okay? So that's factoring. That is definitely the hardest part, and we will work on it. Super important, though. Once you're done with that, these are now what we call factors. This right here is a factor, and this right here is a factor. So to finish solving it, we put those factors equal to 0. So we do a minus 10 equals 0, and a plus 4 equals 0. And then we go ahead and solve those factors. So 2 separate equations. So to solve this equation, I would just add 10. That goes away, a equals 10. That's one answer. And on this one, I would subtract 4. 0 minus 4 is -4. So those are my 2 answers, 10 and -4, okay? And we'll get into geometry, like why one would work and not the other, but for now, that's what I want, okay? And I know this factoring piece is going to be the challenge, but we'll get there, okay? So let's do another one. Pause and write this down if you need to, example 2. So, step 1 is to make it equal to 0. This does not equal 0, this equals 12. So I need to get that 12 to go away. So the only way to get rid of it is the opposite. The opposite of a +12 is a -12. Well, where am I going to put it? Am I going to put it underneath this b squared, the b, or the constant? And the answer is we're going to put it underneath that constant because these are like terms. So the b squared comes down, the plus 5b is right here, and then negative 2 minus 12 is negative 14 equals 0. So that's perfect. That's step 1 equals 0. Step 2 is to factor. So we put our parentheses. These things have to equal to b squared, and that has to be b times b. B times b multiplies to b squared. These right ones have to multiply to 14. Again, I know it's negative 14, but we're just going to say 14 for now. What multiplies to 14 is 1 and 14, 2 and 7, and that's it. Okay, so those are the only two things that we have. Which one of those can add or subtract to a positive 5? Well, that's going to be the 2 and 7. Okay, so let's say I put 2 here and 7 here. They can't both be positive because that would be 9. Since it's positive 7, it would be a plus 7 minus 2. Because positive 7 minus 2 is a positive 5. Again, that step right there is the most tricky. And then we just solve. B minus 2 equals 0. B plus 7 equals 0. If I were to solve this, I would add 2. So B equals positive 2. If I would solve this, I would subtract 7. And 0 minus 7 is negative 7. So again, this step right here is the challenging part, the factoring one. Let's do one more and I'll let you be on this. Okay? So I got a whole lot of stuff going on here. I got to solve it out. One thing I want you to know is whatever letter is squared, m squared, x squared, whatever, I want that to be positive. Let's make that like more of an S. I want that to be positive. So I need to make this 0. I could move all of this to this side and make it equal to 0. That's a possibility. Or I can move all of this to this side and make it equal to 0. However, I want these squareds here to stay positive. Because of that, I'm going to move this to this side because that will still be a positive number when I do that. So the opposite of positive 2m squared is negative 2m squared. Okay, that goes away. 3 minus 2 is 1, or just m squared. I still got to get rid of this guy, so I'm going to minus the 4m. And you'll notice there's no m here, so I'm just going to kind of put it here. I can't really combine that 4m with anything. Now let's talk about order. Which one goes first is m squared. Would the regular 4 or the minus 4m go next? And it would be the minus 4m. It's always letter squared, letter, and then the other number. And now that equals 0. Okay? Some of y'all might do that in one step instead of 2. That's fine as well. Now let's factor. M squared has to be m times m. What multiplies to 4 is 4 and 1, or 2 and 2. Which one of those can add or subtract to negative 4? Not 4 and 1. That would add to 5. It would subtract to 3. That's not going to work. Can 2 and 2 get to 4? Absolutely. So 2 and 2. But it has to be a negative 4. Negative 4 would be negative 2 minus 2. Somebody say that. Negative 2 minus 2 would be negative 4. And then negative 2 times negative 2 would be a positive 4. So that makes sense on all accounts there. Okay? Let me erase those little lines. We're going to say this equals 0. We set m equal to 0. Now, if I do m minus 2 equals 0 and m minus 2 equals 0, both equations are going to be the same because they're the same equation. So we would add 2. And so m equals 2. And then technically if I added 2 over here, I would get m equals 2 again. I wouldn't necessarily write it twice. It's the same number. I would just say that m equals 2 because it's 2 for both of them. Okay? So that's the quadratics. That's something that you learned last year in Algebra 1, but we're going to keep practicing and working on. And again, it gets way more complicated than that. I'm giving you the simplest factoring that we have, and then we'll expand later. Great job.